Start, sir.
Okay, thank you. So yes, so far I see this time I'll just share my screen. Okay, so you just see what you have done. So yes, just a sec. Let me put out the correct screen. So this is our course page now. Is it visible to you all? So this is our course page you see. So what you see, you have made it big this time. So yes, this is one of the highest enrollment robotics program this time, and you see almost one third of you have registered for the course exam also. So that is one of the best thing that I could see this time. So what I see, almost 3055 have enrolled and 1051 have enrolled for the exam also. So that is very good ratio this time as compared to my previous runs last 3 years and as compared to any other courses in robotics. So that makes it very one of the most popular course in robotics. So thanks to everyone for making this happen. And you see currently week 5 is complete, right? So by now you see you have learned quite a lot of things which are quite unique to this course. One of them being a mechatronics approach that I have told earlier during introduction. So electrical actuators, drives, stepper motors, BLDC motors, all these sensors and motors now they form the prerequisite for any robotics learning course when it is used in a applied sense, you see. So the kind of motors which were very specific to current day robotics, that is cobotics, is BLDC motor, and earlier robots were high payload capacity robot were using industrial servo motors, servo drives. So these were covered in this course already. That forms one of the most important topic of this course. Others were technical specifications, somebody who wants to buy a robot, to compare a robot, or to put a robot for a particular use, to design a workspace for a robot. So this was very important. So I covered all the technical specifications as per ISO standard definition and ISO standards, what all govern to define all those, no? So keeping in eye all the ISO standards relevant to this was also covered. So this was an industrial approach to teach industrial robotics. So that is one very good thing in this course. So first 3 modules, I hope you have enjoyed quite a lot. So even in week 4, week 5, you have done already, I think. So that covered DH parameters, forward kinematics, inverse kinematics. So we have literally covered various types of industrial robot kinematics. One of the fundamental being the elbow type of third link joint that we have covered. That is the most popular type of industrial robot made, be a KUKA or FANUC or ABB, Yaskawa or any industrial robot you tell us. So that type of inverse and forward kinematics was covered to the point, means I have taken an industrial robot, split them into halves, links and all, and started doing the DS parameters, did the forward kinematics. The way I did forward kinematics, I started from the base center point to the tip of the robot where actually forward kinematics normally should be done. In quite a lot of books, you may get confused because it doesn't cover from the base of the robot, it covers from the first intersecting axis and to the wrist center point. So that is not a good approach. So I would suggest follow this. This is one of the best approach which normally industrial robot controller also uses it. And same with inverse kinematics. I have used the similar way to do it. So I covered almost around 6 degrees of freedom robot in detail, starting from 2 DOF, 3 DOF, 4 DOF, 5 DOF and 6 DOF. That is done. So you have almost covered the foundation of industrial robots. So most of the industrial robot works till here like this only. Okay. So they work with forward kinematics. That is very important. You should know it. You should know the DS parameter. If somebody wants to tweak in with the machine data file at times, okay, so you can do that also and still your robot will work. Okay, so that is the takeaway of this course which I assume. And then in later weeks from week 6 onwards, you see there is you will directly begin with something very, very fundamental to using an industrial robot, right? So week 6 has started. So you might have you will go through industrial robot installation commissioning. So if you have bought a robot for your academic institute, how to install a robot, mind it, these things are not, I cannot suggest a book. Even the books which I have discussed here, these books don't have those chapters. So where are they? They are there in the technical specification sheet, installation manual, standard manuals of those particular manufacturer for which installation you want to do. Let's say if it is a KUKA, download the KUKA installation and commissioning thing that is there in service manual. There are multiple types of manual you can download from their website. So I would suggest, instead of going through book, you can go through the data sheet that will tell you very much in detail. So this course essentially extracts the thing with an academic essence. I have put them here so that someone can do this. So it is very much relevant for industrial people how to do installation and commissioning, even for teachers who are purchasing robots for their labs. It becomes very, very useful. How to do to TCP calibration, this is not there in textbooks, but without this mathematics, tool center point calibration, which is there directly as an apprentice, if you know, it is not much of an use for at least UG, PG and PhD students. For them, very much mathematics is covered. External reference method, orientation calibration. So all these mathematics are here apart from how to use them, right? So later portions, next week is week 6. Later portions, similar contents are there. Calibration of industrial robot system like rotary turntable, linear rail. So putting the robot to use becomes very much conversant. You become very much conversant to that. Others are again some textbook matter which is here, week 8 and 9, that is statics, robot dynamics and all. Again you will see some practical things. So you see, this course is a very good mix of standard academic curriculum and industrial essence, right? So that makes this course very much useful for somebody who wants to do a robot, and that justifies its name, that is theory for implementation. Okay, so if at all you see, so far we have covered all the forum queries which were there, so I won't discuss it here, but if at all you have further queries, you can always come to the forum. Apart from the text matter of the course, if you have any query, you can definitely come here. Start, sir. Okay, thank you. So if at all you have any query now, you can always come back to me, okay? And then you see you have all these now. So yes, I'll wait for few queries. If you have any, I'll cover them here. Yes, good afternoon. I can see the queries. You can key in directly on this page. Okay, the host can read it out for me, or maybe I can directly read it from here. I see quite a lot of latency is there. That is normal. So I'll wait for a few moments, maybe 1 minute extra, and see if any query comes out. Yeah, somebody came in. Yes, well, IDK, I don't know what is his name, but yes, it looks nice. So yes, sir, is ROS used in industrial robotics? At times, yes, but not traditionally, because robots in the industry needs very much of a reliability. ROS becomes a platform for research most of the time. When you don't have a sensor, maybe you can have a virtual sensor test your robot. So, and you have lot of libraries around in the ROS network where you can download, plug in and play. That is for academic purpose, but latency is lot. If you connect it to any hardware, it may not work properly, right? So those issues are still there with the ROS. So that is the reason ROS because of reliability reason. The kind of know-how which is required to use ROS for any robot is literally very high. Okay, so you don't expect nowadays robots have, it is already more than 60, 70 years now. First industrial robot was put to use in I think 61, right? So it is so many years, it has stabilized a lot. So what happens now? Um, Apprentices are doing programming. How do you expect them to learn ROS and do the programming? So make it so much modular, so much popular, so much simple. ROS is not a most adapted thing. Okay, so if at all you are into research, okay, ROS you can use it for designing thing, for testing your stuff. But when you want to develop your own robot, try to develop, come up with the standalone codes which can run the thing. Earlier days, people used to do it. Before ROS, robot existed. It existed much better, right? People used to make robots, right? So we are still make it, but with ROS now, it sometimes make earlier learners very much handicapped. So I would suggest don't go to ROS right at the moment until unless you write your own first code of forward kinematics, inverse kinematics, a simple dynamic equation of motion you can solve, right? Do ODE 4-5 to solve it. So until unless you are okay with fundamentals now, I suggest you don't go for, if you are a learner, okay, if you are a learner, everyone is learner here, but yes, for at least UG and PG, ROS should come much later. Okay, so ROS is for advanced research, but definitely not for application users, reliability users, industrial users. Okay, because things here are very much settled. Okay, and still research is on with standalone codes. Okay, that is one question. Other one that I see is the final exam. Do you have remember the names of drivers? No, not at all. You don't need to remember the ISO standards at time. It may be there during assignment, course modular assignment. Why? Because you have just covered the module and questions are asked immediately after that week. So that is quite okay, easy. You can refer them and you can answer them. That is fine. But yes, in the end exam, when you don't have any references, learning all the names of ISO standard and Beckhoff or any other drivers, that won't be there. So don't worry, all will be MCQ type. But yes, I tell you, all the questions will be directly from the videos that are taught, the notes that are shared, sometimes from the references. Not even 1 to 2% will be a random out of the way question, but that will be there. Don't worry. That is the requirement of the course also. So that will be there. And yes, you can always refer the data sheet and all. What is taught in the class is very important. So that is how we'll go for the end exam. Okay. Last time there were very good scorers. Scorers were from the teacher side also. That was very good news. So teachers stood top. Okay. Elite users and all top rankers were, quite a lot of them were teachers and good academic learners. Okay. Yes. Any other question? Very good to see you all at least online this time. Okay. This is one of the very best place, when I am live and you can ask me not just the contents of the course, you can ask maybe a career type of thing, how robotics career is made, right? So robotics is a very fetching subject, there are huge hell lot of means discoveries that are on already. India needs people in robotics, right? So you must have heard Operation Sindoor, Operation this, Operation that, but nobody gets into making of a robot. So I would suggest few of you take up this. Students are busy after maybe good package in the campus. That is fine, equally good. But at least for the teachers, for researchers, for industrial practitioners, I would say that you take it up as a serious thing. This won't be, I have personally have handled quite a lot of consultancy projects while I was doing my PhD. For PhD, you also can make this earning source at times. If you are good in practical robotics, it can fetch you. You can do consultancy also. right? So you side by side you learn how to practice robot as a consultant, right? So that will fetch you money also. Right, so that is the case. In my case, I am not just a teacher. I am also running a company which is known as Adusa Robotics and Private Limited, Robotics and Automation Private Limited. So you see, I am running a company, I am teaching. So same type of parallel thing you also can inculcate in your learning habits, right? So that is very, very important. Modeling, yeah, somebody asked about modeling. Which software is used primarily in the industry? See, modeling is your domain, right? So there are existing model. If I talk about dynamic model, so there are maybe Ricardine is there, Redisim is there. There are many Lagrange-Euler formulation is formulated and kept as a library. So modeling is there everywhere. You can use any of the library, and while they provide with API, you can use them as a plugin for your own Python or ROS code. That is very easy. Okay, but in case of modeling where you have to have maybe some kind of visualization, then ROS have visualization tool as well where you can use. RViz is there, right? You know all that. So that is always there. Or Copilot Sim is there, right? Virtual robots are there. So there are few training tools like Robo Analyzer is there, which I am also using for this course to teach you all. So these are a few software which are used to visualize a robot particularly, right? So that is there. Bharat Rabal, our university exam date is 14th November, NPTEL is 2nd November. So still you have enough time, you can prepare for your end exam. NPTEL exam is on 12th, 2nd, so that is okay, that should be okay. So that is what I tell you. Prepare now, do the modules correctly, go stepwise, right? Don't do last moment study. In that case now, it will be difficult managing your own course and this NPTEL course. So as you know, all the questions are going to be from the videos. So do the videos correctly, do the videos well, and appear for your assignments well, which are there at the end of every module. So do that well. I am sure you will be ready for the end exam as well. It is going to be very much similar. You don't need much of a preparation there. Okay. I am studying BE robotics. How should I prepare for my career? So as such, career of robotics, it's a very vague question because you see, um, robotics is applied. The kind of robotics that we are dealing with is industrial robotics, which are arm like. It could be a drone, it could be underwater robot, right? It can be deep sea mining robot, space robot, or asteroid mining robot. It can be anything, right from underground to the space. So all has a different kind of prerequisite. Okay, so choose your field correctly and come back to me. Definitely I should be in a better position to answer you. Robotics as a career, these type of courses, the one which you are having it now, definitely would be a very strong foundation as far as mathematical aspects of robotics are concerned. Okay, sometimes in this course at least you have implementation aspects also. So doing this set of course will be very, very helpful. Okay, so follow-up course could be a collaborative robot course which I have in the next January session of NPTEL. So I have a follow-up course for this. So that will prepare you for modern trends in industrial robots, which is cobots. So that will be there. So following will with all those now you will be ready for your thing. Then you may prefer doing some higher studies in that, or maybe start doing your own consultancy. Try to use the tools of the industry. Okay, so I am covering Beckhoff for no reason, but there are similar tools in the industry which are used to make robots. So try do stop using, I would say, ready-made kind of PCBs like Arduino and all to run your motors to say. Try to run with your own PCB, right? Try to get into that. Arduino have not seen more than 20 years so far. And before to that, robots, even people were doing it still, right? So don't depend on them. Try to make your own PCB, try to use PLCs, try to use your own fabricated jumper wire, terminal connector, PLCs, right? All industrial stuff. That is how you can build a career in robotics. Otherwise, it will all be a mature kind of toy making or maybe a hobby kind of robotics, right? So be mature, try to use that. NVIDIA Omniverse, what do you mean by that? I don't know. NVIDIA ISEC Omniverse. Yes, that is there. Sir, what is the difference between 7 DOF, 6 DOF? How many degrees of freedom do you have? Degrees of freedom, it is number of independent definitions that is required to constrain a robot, define a full robot, right? So your arm is a ball socket joint here, right? So it has 3 degrees of freedom here. You can do this, you can do this, you can rotate about its own axis. This is a ball socket joint. Another one is here, that is elbow, that is one. Wrist is the intersection of roll, pitch, right, and yaw, right? So roll pitch, 3 intersecting axes, 3 here, okay, just like ball socket joint. So 3 plus 1 plus 3, it is 7 DOF, right? Industrial robots has 6 degrees of freedom. So it can position and orient an object in space, but 7 DOF robot can orient and position in infinite number of ways. So that is what is there. So that is what, if you want to learn further about those kind of kinematics, I am covering that in my next course, that is 7 of robotics inverse and forward kinematics. So that is there in collaborative robot course, that is going to come next. So don't worry, even this definition is quite good enough to understand it, I think. Okay, so that is what we just repeat that lecture which I had here, no? That was there in fourth module, and then finally fourth module, yes, fourth module, degrees of freedom and transformation. So I have covered very much in detail that. Just try to go through once again. What is singularity in third joint? Singularity error in third joint. This is again a very vague question. Be very specific with that. Maybe you can write it down in our forum. Our TS will help you to frame it properly, this question. Okay. Language only English, few helping others, language translation. I don't know what does it mean. We are trying to make this course also available in Hindi and other languages. So that is in process. If you can volunteer them, you are welcome. I'll suggest your name to NPTEL. You can do that. Your name will be acknowledged and you will be paid too. So that is another very good thing that you can do. Okay. Sir, will we be provided with internship? Definitely internship opportunities there with this course. Okay, that will be provided, that will be offered by NPTEL to top rankers. They can take it. Okay, that is always there with the course. Otherwise, feel free to directly come to IIT ISM Dhanbad during SRIP program, Summer Research Internship Program, through usual application process and shortlisting. You may be given chance, so that is always there. Okay, so internship is there. How to open business in future with knowledge of robots? That would be a different domain altogether to cover it here, but yes, try to learn the fundamentals first, right? The tools of the trade you should know, right? Don't just learn the mathematical aspects, try to learn the implementation aspects. So this course is very much about that. You are not just taught how a robot joint angle is required to achieve to a position, right? So how to achieve that particular angle is also there. A kind of motor which can do that, that is also there, right? What kind of sensor which can give you feedback of the joint angle is also there. Your mechatronics approach to robotics is here. So with that knowledge, definitely you should be able to build at least a small 2-link arm or a 3-link robot, which is a special mechanism. You can make it to start making things. That is the key. Start making things, start opening things. Don't get scared. Don't restrict yourself to any domain also. Don't restrict yourself to any domain. I am from mechanical, I cannot do this. Robotics is an interdisciplinary subject. As I told you, prerequisite for this course was very, very fundamental. High school physics, vectors, matrices. That's all, is it not? A small bit of calculus. That's all. So I think with that knowledge, you can go to a level where you can deal with machines at least. Okay. So I think it is quite good of a course which can answer your query quite well. By the end of the course, you will feel quite confident. Okay, very good that people are coming up with question. This time I am very happy with so much of turnover. At least you see 3000 of you have enrolled, one third of that has enrolled for exam. So people are taking it seriously. Quite a lot of universities have adapted this course as their own curriculum also. That is thanks to all the teachers who have done it possible, made it possible, right? So yes, that is very good sign that yes, this course is picking up very well. It is one of the highest enrolling course now in India, and mind it, NPTEL is a very good platform to learn anything. These are real professional course without any um, monetarily benefit much. Okay, so we are not kind of people who just look for money. We are giving this knowledge for free to you all, right? So NPTEL is a very good thing that government has come up, Ministry of Education have come up with, where you can learn the thing, okay, for free. Only certificate and exam, and that is token money that is taken. That is very good platform. Okay. Yeah. Any other query? Thanks a lot for putting so much of queries. I am at least engaged this time. I am happy. Yeah, sir, I am pursuing second year PG in AI. Very good. I almost covered this subject MLDP, NLP, LLP. So want to combine these topics to apply robotics field. How can I do it? That depends. You see, I won't say you directly go for AI implementation. There are a lot of things which were running since long time. India is unable to make it. Without AI, we saw the day when whole of the industry was flooded with robots. Is it not? We cannot make a single arm so far. Why? Because we cannot run actuators. We cannot make actuators. That is the problem actually. You directly start, see, AI is a tool. Let's say you can solve in a closed form inverse kinematics of a robot. If it is a 7-DOF robot, optimization problems are there for various things which can solve for that also. So there are closed form solutions, mathematical solutions existing, right, which can give you results in real time. Why do you want to go for AI? AI definitely you can use it for inverse kinematics of 7 degree of freedom or more kind of robot. When you really need it, go for AI. Okay, let's say you want to have a conveyor belt with multiple chocolates lying around. You want to segregate them. Maybe you can use vision with AI. That is one way you can use AI in robotics. So that is one of the most prominent place, most common place where people use AI. That is the vision based task, right? Your robot is approaching a door, you want to open it, you have to segregate the handle location to rest of the door access location, right? So in that case, you may use AI to figure it out, right? Door handle, right? You want to insert a plunger in a barrel, right? Peg in a tube problem. So then maybe you can use AI to figure out the forces, how they are interacting with each other, how to get things done. Learning techniques can be done. RL methods are there. So those to implement, finally, you may require AI. So those are the places where you can use AI. That doesn't mean I am restricting users. At least know the fundamentals of robotics first, because implementing no cannot be done without knowing the fundamentals of robotics, not just AI fundamentals, right? So robotics challenges are not much tough as such. They are simple AI challenge even if it comes. Okay, it doesn't require research in AI to do problem solving in robotics. It requires more fundamental robotics knowledge, and then you can definitely put in AI as a tool to solve your problem, and most of the problems are solved that way. Okay, there are modern robotics which have developed a robot holding a plate, and anyone who touches any place of it without being a touch screen, it can detect it like a touch screen. There are publication right in 2024 also I saw such publication which were AI dependent. So those researches, just browse through those researches. Maybe you can come back to me on forum. No, I can suggest you some research papers, recent research papers which have implemented AI in industrial robots kind of. But there are no end to it. It can may not attract you also. Okay. What is industrial robot cladding application? Okay, sir, can be laser welding be done in circular motion? See, robot is a tool which can give you motion, which can handle some payload. If you can do it with your hand, you can do it with your robot. Cladding is an application, right? Similarly, laser welding is again done in a circular manner without rotating the job, but instead giving the trajectory. Yes, it is doable. Yes, it is doable. If you can imagine something which you can hold in your hand, you can do it. So robot has got the same capability. So yes, you can do it. So robot can do it as well. It is just a programming matter, right? Some companies to apply after completing this course. There are quite a lot of companies. See, India is importing a lot of robots. So at least during installation and commissioning, they need people who can do maintenance over here, do servicing, do marketing, right? So provide solutions. Integrators are there. So those things are still very blank space, okay, where people are not getting in. There are freelancers who are earning a lot through robot consultancy. I told you, even during my PhD, I did few installation for Kinova Jacko robot at few universities, right? So that is something which because of my knowledge I am able to do it. So yes, you don't need always to take up a job. I established my own company who is making a robot for universities now. That is because that is because of in-depth knowledge of robots and its implementation. Okay, the mechatronics thing behind the robot. So that is very, very important, right? So yes, after applying, you can directly apply to, there are few Indian companies, okay, Adverb is making one, you have already Grey Orange is there, Warehouse Robotics company, Peak Robotics is there are many robotics company, right? Sir, how can we connect with you? IIT ISM Dhanbad, I work here, right? You can just browse through my page. You have my email ID. You can connect with me personally. Course related thing, I would suggest you always come through proper channel, that is through the course forum only. Okay. So yes, Ayush Goyal, sir, what do you mean by system integrator? Integrators, you know what they do. Um, you have a robot, you have other systems like conveyors are there, you have controller, you have multiple sensors, data which are coming in. So what integrator basically do, they provide solution for a given problem. Okay, they create the assembly lines. Okay, if it is an assembly line for a car, so they program the robot, they integrate the robot with other automated systems in the workspace. They talk to each other, right? They have sensors, they have actuators, external actuators, they talk to each other, they do all those things. They integrate the system, put the robot for that particular application. That is what is robot integration. Got it? So that is very, 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 very important. Without that knowledge, no, just robotics won't help you. So robot always comes as a package. So automation is the bigger picture. Robotics is a subset of automation. So industrial automation overall requires robots to be integrated in the system. Got it? Yes. Any other query? Very good. People are coming up. New people are coming up, not just a few. Very good. Make Indians great again. Definitely we will be great again. Don't worry. Work on hardware. I am always telling you. India, you have too much of manpower for AI, robotics, ML, but very few who can make robot, who can make actuators, integrate sensors, right? So until unless we do that complete, you cannot do that. Consultant, who are consultant? Let's say, I'll give you an example. Let's say you have a seller coming to your university who wants to sell his robot. Okay, but he's a sales guy. He cannot, he know how to operate this robot maybe, when it comes to your research, you might have faced a lot of difficulty to program this robot for your application. So consultant, what is his role? He basically, you as an academician, you know better your job. So you find people like you who they have requirement the way you had it, right? So these people who sells robots to you cannot provide consultancy to academicians, right? They have unique challenges. They have very difficult challenges at times. So you as a academician can become consultant to those specific problems which are very rare. They are not common to industry. So that is what we do. Okay, when we provide our robot to academics, okay, we don't just provide robot, we provide a solution, right? So as a consultant, I tell them, okay, you will be requiring this equipment to do this thing. Okay, so consultant basically advises the thing. They may have uh, collaboration with integrators who integrate it for them, or maybe you have a complete team who provides full solution. You provide the robot, you provide the BOM for the automation thing. You also integrate the thing, give it as a solution, right? So that is what is the consultant's job. Got it? So it is very fetching, very fetching. Okay, it is much higher. Consultant nowadays in robotics, they earn as high as 25,000 per day or higher at times. Okay, so let's say your robot has gone bad, sailor will connect to you. He'll ask you, go to that venue, repair that robot and come back. Right, if you know how to handle that, you are a skilled manpower. Right, you can charge 25,000 per day and just to mend that robot. Right, in India, those people are very less. Okay, they are trained apprentices, but even engineers can go there. Right, because the salaries are high. Got it? Hope I have answered quite a lot. So I should see good amount of questions in the forums as well. Very few technical questions has come up. Very good that you have come up with very much generic question. It is very good. Applied question, how to become consultant, how to become integrator, right? How to use AI, ML and all. When to use AI is very important question rather than why to use AI or something like that. Okay. If there is no question, is Attendant Automation Expo 2025 in Mumbai. Why there are very less manufacturing units? You have the better answer for it. Would you be loving to make a robot after this course? So that is where the question answer lies, right? Why there are no manufacturer for harmonic drives? See, the technology is revealed. Patent has expired. Who is stopping you? Got it? Having a GEAL, it is not that we are not making it. There are few companies who have come recently. I have come across N-Motion recently in one of the conferences called AIR 2025 that was held at IIT Jodhpur recently, Advances in Robotics. I saw few companies who are making BLDC motor drives, right? So that is the servo drive which they are making, right? I have seen quite a lot of startups who are making BLDC motors also. Got it. So we are making it. At least the actuators have started. Now the combining them together, we can make the robot. Technology is not hidden, right? It is well published. Patents have expired. Nobody will stop you. Why there is less? It is because of the intent to do so. People don't want to take risks. They want to work for robotics company rather than making a robot startup. So that is something which is picking up these days, and yeah, you can do that also. Yes, Ayush. So that is the problem. Sometimes because of no material manufacturability problem, at least in case of harmonic drive, making that flex ring was a problem. That is a material problem. Manufacturing so thin flex ring, no, is another challenge to make it in India. Very difficult, right? There are very few manufacturers, very few machinists. skilled manpower, they are not paid well, they don't want to work for that reason, right? If they can be paid for just turning a shaft, why will they make such rings? You have to pay them well, right? So apprentices are paid not more than 8 to 12,000, and they have the skills, but they don't want to put their brains to do carving to that extent, right? So there are few technical glitches also, but most of them are the logistic glitches. We have machines, at least in India, we have machines. Materials for this is well known also. Okay. So, sir, I have sent link and connection. Kindly allow me to email CV. My CV, you can download it from my institute website, that is always available. Your CV, I can see it on the LinkedIn. I normally connect with people on LinkedIn. Those who are passionate, I am always connected with them. So maybe we can exchange some thoughts over there also. Good, Ayush. I have worked extensively, very good. As a software developer, I would suggest you also try about something called hardware development, right? It is not that you need to be a mechanical engineer to make things. Machines will be making, you will have machinists who will be doing it. You need to design, that becomes a software part of it. Okay, if that is the question, I think we are done with it. Any further query? I will wait for a moment and then I'll log off. Ayush, you have done any CAD course here? Designing, first of all, starts with very much fundamental, that is mechanical design. How to design a shaft, how to design a cantilever beam, right? So those fundamental design aspects, if you know it, you can start creating things with the strength aspects also. Right? You cannot just design a link without having understanding of a cantilever beam, right? So few smaller things now you need to come up with. I would suggest fundamentals of designs. Few books are there. Machine design book by Peter Norton is there, or many other design books you can go through. Those are few mathematics, but I would suggest, if you are not from mechanical engineer, you can hire somebody for that. But yes, creative design you can always do using SolidWorks, CATIA, ProE and all. Those you can use it. So you can imagine things, you can make things. Maybe you can take up a reference design. These days it is available, or quite a lot of CAD, GrabCAD and all those internet links also. So you can start doing few things at least. First thing, you should be very much creative, innovative, right? And rest things are already revealed, right? Whole of the disassembly, no, you just go to KUKA website, you can download the KUKA, all the links. Okay, you can download it from there. All the STL files are, you can 3D print them, look closely, design your own, right? So Creo 3D, yes, it is a good parametric design software, you can do it. Yeah, okay, so somebody who wants to work for free, Autodesk Inventor is free for students. At least every year they renew it. New version, you can download it and you can again renew it for next 1 year. So don't use pirated softwares, no. Someday it may restrict you severely. So yes, because all the CAD packages are same. A little bit here and there of icons and commands, and you can get hold of that in no time. So take up a good one which doesn't require license, at least for students, and make your things, design your things, 3D print the things. Yeah, okay, and maybe at least with the smaller things you can start doing it. Start doing it, that is the first thing, right? And do it with discipline. Do it with discipline, I mean, don't make toys, make robots instead, right? Don't make toys. Jumper wires, double-sided tape, right? Improper terminal connectors, breadboards, jumping, hanging wires, loop-up connectors. So those things should be avoided, right? Arduinos. If you have to design Arduino, Arduino itself was an open source. Why don't you make your own circuit? Just bare minimum component which is required to run a microcontroller is nothing but a maybe just a reset switch outside and a power supply. That's all. Nowadays, microcontroller comes with inbuilt clock supply also, right? And just program it and do it, right? Learning Autodesk Fusion. Good. Autodesk Fusion is very good. That is free. There are a lot of tutorials. No, you can use that. Autodesk has got very good help desk also with tutorials. You pick up any YouTube series, sometimes quite a lot of users, they have made their own channel. I see starting from a cube, revolve feature, this feature, that feature, you can start doing it. IIT Kharagpur has a very good course organized by Swiss Workshop. I see they have that course announced every year twice, I think. Okay, you can enroll to that, go there, learn that. Foreman Training Institute in Bangalore, learn CAD, right? So once you learn any of the CAD software, no, you can extend that knowledge and things are the same, right? Anyway, I am diverting too much from my own course. So yes, sir, for humanoids, what all should we learn after course? Any particular course? Yeah, for humanoids, no, all the links and the joints are compliant. So there is a course coming up next. My course itself, with this as a background, that will be quite easy course. 30% of the content is almost matching. So collaborative robots, you can do that course next. That will help you to create compliant robotic structures. Okay, so that would be a next step towards humanoids. Okay, Yash? So that is a unique course. That is the only course existing throughout internet on that subject. It is force control of industrial robots. That's good. Good that you have experience. Try to explore things. Maybe we can connect personally later on. For today, I have limited time, so maybe we'll have to stop it here, right? Any specific query related to the course? Thanks a lot for connecting. What is the real world challenges during design operation maintenance? When I have seen a service engineer, most of the time I have seen people who come for service, they are always connected to someone online because they themselves don't possess that kind of know-how. This course tells you how to the basics of actuators, basics of sensors, basics of ios, right? Following this course you may do any um, automation course on PLC or those kind of course, no, that will help you to design, operate and maintenance industrial robot running a servo drive. Servo drive could be Siemens or Yaskawa or maybe any servo drive, right? Those motors, how to run them, how to get through the data sheet, okay, how to handle the field bus, how to handle IOs, industrial IOs. So if you know them all, maybe you can do all sorts of things. Anyway, I think that should be quite good answer for this. Okay, thanks a lot. So yes, there is no more query. So I think we can stop here.
Okay, sir.
Okay. Thank you, everyone. Thank you, IIT KGP, for hosting this out. Thanks a lot.